this mini video is to talk about logical implication and a special case of it. So let's review the definition. A set of sentences P logically implies a sentence Q. Written P logically implies Q with this double turnstile. If and only if every truth value assignment making P true makes Q true. In other words, there is no instance where both P is true and Q is false. If such an instance exists, then P does not logically imply Q, written as such, with a nice slash across. And this instance is called a counterexample. In Latin, it's this phrase that I'm not even going to try because I would butcher it, but it roughly translates from falsehood, anything follows. Now, there was another video I did that talked about the relationship between the logical implication symbol and the conditional symbol. And the difference was really this applies to an individual row in the truth table, whereas this applies to the entirety of the truth table. And so this, we consider all of the rows. So you can think about this being the conditional, but we have to check every single row to make sure it's okay. So let's do an example. We'll do the example of A, not A, logically implies B. Now, B has nothing to do with A. It has nothing to do with not A. But let's draw the truth table and see what happens. So we have A and B. And then we have not A here, and we'll draw like a nice bar to separate the variables. So we have the opposite of A over here. And then we're going to have the double bar, and then our conclusion B, we're just going to copy that over. And now we're going to look at where our premises are. So our premises are this row, this column right here, and this column right here. And then this here is our conclusion for the argument. And so what you're going to do is you highlight all of the rows in which all of your premises are true. This is true, false, so they're not both true. True, false, they're not both true. False, true, they're not both true. False, true, they're not both true. And then you would check your conclusion to see if there's any falses in the highlighted rows. And I didn't have to highlight anything because there was no instance that satisfied all of the premises. Now, another way we could look at this on how to solve it is you could kind of think of this as each row we're looking at this and this. We take the conjunction of it, and then we do imply or conditional, so the arrow, to the conclusion. Okay? So we have true and false. Well, when we take the conjunction of that, we get false. And then false, conditional true, so false arrow true. When we looked at the truth table for this symbol here, that is a row where it'll be true. Again, here we have true and false. If we take the conjunction of that, according to our AND table, this is going to be false again. Because remember, both of them have to be true. And then we have false, arrow, false. Well, in our table for this, we definitely know that false arrow false is also true. Again, we have false and true. That's going to be false, false, arrow, true. That's true. And then false, true. That's going to be false because false and true is false. And then false, arrow, false is also true. And then if you look here, if all of these are true, then you know it's logically implied. If there's ever a false here, then it is not the case. It would be P, your premises does not logically imply Q. Or alternatively, Q is not a logical consequence of P. And if we had something like this, then you just find what the values are for all of the letters in your premises, and then that would be the counter example for that row. And that's the video.